So this will match up with 7.1c, and I'm going to call this area and apps. So area of triangles using law of sides, and then also applications using law of sides. All right, so first thing is, and we are not going to take the time to derive this because ain't nobody got time for that. We can find the area of any triangle using law of sines. It's kind of just like a rearranged law of sines, including that height, because triangle is 1/2 base times height. So the area of any triangle using law of sines equals 1/2 BC sine of A one half AB sine of C, or 1/2 AC sine of B. So there's 3 versions of it. They all use all 3 letters. 1/2 BC sine of A, 1/2 AB sine of C, 1/2 AC sine of B. So you use 2 sides and then sine of the third angle. That angle will always be what's called the included angle. So it'll essentially be a side angle side. The included angle is the angle in between the 2 sides that you're given. So we're going to do one example of this because it's literally just like a plug and play formula. So our example is to find the area of a triangle having 2 sides of lengths 24 meters and 10 meters. With an included angle of 62 degrees. It'll always have to be an included angle. And then we can use any version of this because we could draw a triangle and label the angle A, and then the sides would be B and C. We could label it C, and the sides would be A and B, or we could label it B, and the sides would be A and C. It doesn't matter. So all we do on this is we literally just say area is area 1/2 times our 2 sides, so 24 and 10, and then sine of 62 degrees. So it's literally just a plug and play formula. You literally just plug in what you know. Again, we're not deriving it. You can just use it. So make sure your calculator's in degrees. 1 divided by 2 times 24 times 10 times sine of 62. And I get 105.95. It wants me to round to the nearest square meter. So that's going to be 106 meters squared. Because it's area. Wait, any questions about that? It is plug and chug. All right, so in that case, the only other thing we're doing today is we're doing applications back of just regular law of sines. So law of sines with sine of A over A equals sine of B over B equals sine of C over C. You figure out your known ratio, set it equal, and solve for your other stuff. We are going to do one example. I'm going to read it to you, and then we'll draw a picture because it's like a whole paragraph here. 2 fire lookout stations are 20 miles apart, with station B directly east of station A. So this is example 2. So we've got station A is here, and then 20 miles away is station B. 20 miles. What else do we know? Both stations spot a fire on a mountain to the north. So there is a fire up here. There's a fire. Okay, then we know, because from each of their stations they can determine this, the bearing from station B to the fire is north 50 degrees east. So that's going to be north 50 degrees east. So this angle right here is 50 degrees. JK, I skipped a line, guys. That's not 50 degrees. The bearing from that one, this one, I was like, that's not east. This one is north 50 degrees east. I was like, this doesn't seem like it's to scale at all. This one's north 50 degrees east. This angle over here is north 36 degrees west. So this is 36 degrees right here. I am so sorry. So basically, from this fire lookout station, there are two people on their little walkie-talkies saying, I can see a fire, this is my angle, I can see a fire, this is my angle, and they know how far apart they are. We are trying to figure out how far station A is from the fire. So that's the distance we're trying to figure out here, is where is station A from the fire. Sometimes it'll ask you to figure out both and then figure out which one's closer, because, like, obviously you would want the closer person to respond. Or you could just, I don't know, both of you hop in a fire truck. It's not stop and do math, but whatever. Okay, first thing that we need to figure out, since our bearings are these like external angles, this angle right here is going to be 90 minus 50, so that's 40 degrees here. And then this angle right here is going to be 90 minus 36, so that is 54 degrees here. And I'm trying to solve for this. Okay, I'm gonna label, since I have the stations labeled A and B, I'm gonna label the fire C. So that's gonna make this little c. That's gonna make this little a, and that'll make this little b. So now I know I'm solving for little b. Right now, I don't know both big A and little, or the big and little version of any letters yet, but I can solve for big C there. So big C would just be 180 minus this 40 minus this 54. So that's 94. So this is going to be 86 degrees here. And then now I can use my ratio for C. So I'm going to do C over sine of C equals B over sine of B. Sorry, B over sine of B. And I know everything except for little b, so I can just plug all of that in. So I know that little c is 20. So I've got 20 miles over sine of 86 degrees equals little b, which is what I'm trying to solve for, over sine of 54 here. Before we solve that, does anyone have any questions? Okay, I can multiply by sine of 54 on both sides. So these cancel. And then I have that little b just equals 20 sine of 54 over sine of 86. And I can throw that in a calculator. 20 sine of 54 divided by sine of 86. And I get 16.2 miles, which makes sense compared to that 20 miles. Cool. Any questions right now? Okay, groovy. I am going to post your assignment here momentarily. I haven't posted it yet, and we have literally like an hour and 12 minutes left of class. So let me post your assignment real quick.